Hello. Hello. I'll be solving a physics problem today in this video. Our given problem is a Jaguar that speeds off and applies the brakes, and it leaves skid marks of 290 meters long in length, and the given coefficient is 0.60. So let's first start by drawing a free body diagram. This is our ground, and this is our cool Jaguar vehicle. So I will list the forces in this free body diagram. So going down is the force of gravity, or mass times gravity. And going up is normal force, which is mass times acceleration. And it says that it applies brakes and leaves skid marks. So applying brakes is going to create friction. So I will list it as frictional force. Frictional force is coefficient times n. So our given variables is coefficient is 0.60, and the length of the skid marks is 290 meters. Ooh, that's a lot. So you're looking at a free body diagram, we can see that the net force acting on the car is going to be equal to the kinetic frictional force. In other words, it'll be the net force is normal force times frictional force. So knowing this, Newton's second law of force is equal to mass times acceleration, we could write that as normal force, and the frictional force is coefficient times n. But to make it simpler, we could write as mass times gravity. So we'll do that. So mass times acceleration is equal to coefficient times mass times gravity. So this is our equation. But seeing how we have the m on both sides, we could just cancel them out. And to make it easy, we'll rewrite the equation. Acceleration is equal to coefficient times gravity. So because we're applying friction on the brakes, we're going to create negative velocity. We're trying to stop. And so picture this on the x-axis will be positive direction. This will be negative direction. So our coefficient will be negative. And now what we simply do is plug in our negative coefficient value, which is 0.60. So acceleration is equal to negative 0.60 times gravity, which is 9.8 meters a second squared. This calculation gives us a value of negative 5.88 meters a second squared. So that is the acceleration that we have obtained, and I will write that here. Negative 5.88 meters a second squared. So the question asking, how fast was the car going? So this is this question deals with an equation of motion. And we will include the kinetic equation of motion, which will be the final velocity squared is equal to initial velocity squared plus 2 times acceleration times distance. So the question asking how fast was the car going, it is not asking what was the final velocity. And for that reason, we'll cancel out this final velocity and substitute with put it in with 0. So 0 is equal to final initial velocity. 0 is equal to initial velocity squared plus 2 times acceleration times distance. So it says how fast was the car going. This indicates past tense, or how was the initial velocity before the wheels became locked. So we're gonna set this on the other side. So we're gonna find out the initial velocity. I will do that by subtracting initial velocity on both sides. And we're left with the negative initial velocity is equal to 2 times acceleration times distance. And to get rid of the squared, I will square root the other side. So negative initial velocity is equal to square root of 2 times acceleration times distance. And lo and behold, we can simply plug in our values that we have, distance and acceleration. So let's do that. So negative initial velocity is equal to square root of 2 times negative 5.88 meters a second squared and 290 meters. Doing that leaves us with negative initial velocity is negative 58.39 meters a second. But because we have two negatives, it's going to be a positive. So you know, like negative times negative is positive. That's what it is. Or negative divided by negative is a positive. So these two negatives are going to be equal to a positive. So initial velocity is 58.39 meters a second. So with our quick overview, we had a given values of coefficient is 0.60. Our distance of the skid marks was 290 meters. We drew a free body diagram and found that the net force acting in the car was equal to the kinetic friction force. And we were more specific with our variables being used. We canceled out the m's, and we found out our acceleration was equal to coefficient times gravity. We plugged in the values given, and we obtained negative 5.88 meters a second squared. We put that into our toolbox, and we used we used this kinetic motion equation. But since it did not ask for the final velocity, we put in 0 is equal to initial velocity squared plus 2 times acceleration times distance. So we wanted to find how fast was the car, or what was the initial velocity of the car before it applied the brakes. So we got the initial velocity on the left side by subtracting both sides, and we got rid of the square root by adding the square root on the other side. And we just plugged in our given values, and we got negative 58.39. But because you have a negative is equal to a negative, it's going to be a positive. So our initial velocity is 58.39 meters a second. So how fast was the car going? Well, it was going 58.39 meters a second. And so this is our answer. Bam. And I hope you are well pleased, and thank you for your time.